Hello and welcome to day 12 of Advent of Code. We are trying to solve every puzzle every day, 2 puzzles per day, and we are using Kotlin to do this. And we are almost halfway through Advent of Code, I guess, with day 12. Let's see what the puzzle has for us. With your submarine, subterranean, subsystem, subsisting suboptimally, the only way you are getting out of this cave anytime soon is by finding a path yourself. Not just a path, the only way to know if you found the best path is to find all of them. Okay, path finding apparently. Fortunately, the sensors are still mostly working, and so you build a rough map of the remaining caves, your puzzle input. For example, start A, B, C, A. Okay. This is a list of how all of the caves are connected. You start in a cave named Start, and your destination is the cave named End. An entry like B to D means that cave B is connected to cave D. That is, you can move between them. So the above cave system looks roughly like this. Start A, B, okay. Your goal is to find the number of distinct paths that start at start and at end, and don't visit small caves more than once. There are 2 types of caves: big caves written in uppercase like A, and small caves written in lowercase like B. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. So all paths you find should visit small caves at most once, and can visit big caves any number of times. Given these rules, there are 10 paths through this example cave system. Okay, we go start A, then we go to B, then we go back to A, then we go to C, then we go to A, and then we go to N. Each line in the above list corresponds to a single path. The caves visited by that path are listed in order they are visited and separated by commas. Note that in this cave system, cave D is never visited by any path. Here. To do so, cave B would need to be visited twice. Yeah. Once to the way to cave D and a second time when returning from cave D. And since B is small, this is not allowed. Here's a slightly larger example. Okay, awesome. I think we will do exactly the same we did yesterday. And that is writing tests for all the pieces. And we have nice test cases here. And here's even a larger example. Awesome. Yeah, so let's switch to IntelliJ and let's start with day 12. Day 12. We create a day 12 file. At some point we will have a part 1 and part 2 function, and we always have a main function where we execute part 1. And let's also get the input. How large is this? Okay. Looks fine, I guess. Let's save this. And then let's switch to IntelliJ. Let's get the input. Here it is. Right. Rename it. Day 12. Oh. And again, I forgot to rename it day 12 txt. Okay. And we will write tests, so let's go and create a test for this. Day 12 test. Awesome. So the first question, as always, is how do we want to represent this data? We will need, maybe we create a cave class. It's a little bit do we really want a cave class? I'm wondering whether we want to just keep strings. So we will need some kind of function that read caves from a string again for testing. It gets an input, and then we will need some kind of caves from file thing that will get a file name. We say file name, and we read text, the whole text, and then we put it into read from string. And how do we want to represent this? I'm almost thinking right now we want the map of strings, that is mapping from any point to a list of all the points you can go to. Let me start with that. Yeah, and I was wondering if this should be a cave. But would that help us at all? And we can do it just to make the code nicer to read. And I guess this is the name of the cave, the value we are reading. So it's a map of one cave to a list of caves that you can visit from it. And let's write a test for that. And let's grab a very simple input, only the first one, simple enough. Let's say that is what we want to read. Whoa. Read case from string. And then we get a cave map. And let's close this for a second. This is to do. And how do we validate that it's the right map? We could create one. Maybe for this simple example, we can create one. Cert equals. How many entries do we want? We want start, A, B, C, and end. Makes 5. 5 entries. And then we want, we can just count maybe for now. Start will have 2. Cave map of cave start. Size will be 2. And then of cave A. A is connected to start, C should be 4. Oh, what's wrong here? Oh, that can be null in theory. And then we have small b. Small b is connected 1, 2, 3, 4 as well. Then we have C, only connected to 1. Small c, right? Yeah. Then we have D. It's only connected to one, and then we have AND, which is connected to 2, but if we are at the end, we are at the end, so it doesn't need connections, but why would we special case this? And then let's see, if we have an input, we first want to get the lines. Let's open the file again. And then we split at the, oh no, we map. And then we need to store both of them to our map, I guess. Cave map is a mutable map of cave to list of caves. And if we get such a connection, we need to first get, how do we call this? Connections is cave map get or default for, how do we, it's the line can be, if we split, can be multiple things, but we only need 2. So it's A and B, and we map to a pair of A and B, and then here we can say A and B again. We get the connections for cave A, or otherwise it's an empty list. Let's maybe make this a mutable list. Otherwise we will have to create new lists all the time, and that is maybe stupid. Otherwise it's a mutable list of caves. What's wrong here? Oh, this is of course a mutable list. Then we add this. Oh, we need to add both directions, I guess. So connections A. Oh, this is ugly. And we put add cave B. And then we need the opposite as well. We get for cave B the mutable list. Now I wish we would have used a string, because creating those cave objects here is ugly. Should we keep strings? Oh, well. Now it's a cave. And to connections B, we add cave. Get our default does add stuff, right? And we return a cave map. Get or default returns a value corresponding to key or default value if such a key is not present. So I guess we still need to put it back. Ah, now it's too ugly. Now, do we want caves? Damn it. Nah. We want strings again? No, let's continue using cave. Because the thing is, we do not know what part 2 is. Maybe part 2 will be easier if we have a cave object and need to remember stuff in it or whatever. So we put at position cave A the connections of A, and at cave map cave B we put the connections of cave B, and now I guess we can just test this. So let's run this. And an X is out of bounds. Where is this? Here. Yeah, we don't want to split this. We want to split at the dash. We expected 5, but we got 6. And which line is that? 6 entries. Yeah, that is actually also what I wrote here. So let's run this again. Okay, it looks like everything is working. Do we want to print them? I don't think so. If this is as expected, then everything is fine, I guess. So we should find all paths. Write this as an extension function. If we have a cave map, we can find path. What is a path? It's just a list of caves. How do I find a path? We start at start. For every... Here we start at start, we collect everything that is connected to start, that is A and B in this example. And then we visit those. Add them to the list of things we have visited. And then continue with this point. How can we write this? We might need a recursive function that gets something else. And that is a suitable list of caves. And continue path. And we give it a cave. That's the one we are at. We give it a list of things we already visited. Of caves. And do we need more than that? No. We still need to... Oh, sorry. a path is a list of caves, but we want to multiple of those. So we return multiple of those. So our first find path function is essentially just saying start oh no, we also need path, the path we already are on. Now we say the path we are on is the start position, cave of start, that's where we start. Our path has only the start. Then we say oh no, sorry, only the start. This way, it's a list and there's only the start in it, and then we get the connections for this. Actually, we can do this better, I guess. We say continue path from cave start with an empty path so far and with nothing visited so far. We return this. So now we only need to implement a recursive function. We are at cave with a path and we need to continue. So our new path is path plus the cave we are currently at, and if cave, let's add a helper for that. If it's the end, it's end, which means name is end. Oh, I was confused why this is all an error. Is end means the name is end. Just a helper to write nicer code. So let's say we are already at the end. Then we can return a list of new paths. Then we have connections from here, and that is get everything from this cave, filter we need to filter those out that are not either large cages. If it's a large cage, this means the first character is null, I guess. How do I get character if I cannot? Oh, I can. Is uppercase. So we want the connections that are either have a cave that is large or where cave is not in visited. Because if we already visited it, or if it's not large and we have visited it, we do not care about it. What's the problem here? Oh yeah, we almost always assume we get a cave, otherwise we can. Well, if we end it here and there is no connection for this, like a dead end, can this happen? Sure. No. There should always be one. Because otherwise we didn't show up here. So let's throw in this case no connection from cave. And then we do this and then current. It's large, or if you haven't visited this. This is our list of connections. If connections is empty, so we cannot go anywhere, then we return an empty list. And if there are connections, then we join them. And this means we map them to current continue path on current with our new path and visited plus the current cave. I mean, we also add large ones to the list now, which is a little bit unnecessary. And then we take all of those. Is this already it? Let's give it a try. Let's find path simple. And we throw in this here, this cave map. Cave map, find path, and then we say number of path, or we can actually assert, and how many do we expect? 10. Since this is a test, let's assert. We only found 2. That is pretty bad. Why did we only find 2? We can print for us. Should we print? Do we want to print? Oh, no, that looks kind of fine. We only want those that are not empty, but that's not our problem right now because we do not get too much, we get not enough. Okay, what is the best way to debug this? Yes, by looking at continue. Test continue cases. So let's say we have this one again. And do we want to simplify this? Before we continue, let's quickly read this. So if it's the end, we return a new path, which is the current path plus the cave. Right. Otherwise, we look for all the connections for this cave. And then we take all of the connections that are large. And that we do not have visited. That is fine. If connections is empty, there is nothing more to do. Otherwise, we continue our path in the current cave with our new path. And oh, this is wrong. With the current one, no, that was actually right. The current one added to the visited list. I wonder if we should print this. Continuing path. Get a rough idea what we're doing. We are at start A, C, print. It's empty. The dead end. Otherwise, we continue. Hey, we found multiple ends, but we are not collecting them. Why is this the case? Why is this the case? So we found this end, return it. The problem here, we map our connections to let's return path here and also add a print. After going deeper, we have this many paths. Okay, we go here, we end up with 1, we end up with 3. Why do we not combine them correctly? Where is it wrong? This here wrong? Otherwise, this is a mutable list of caves. And we have all the connections. And we get new path. And the new paths are the continuation from current. From current to new path and visited plus the current cave. And then we add all of the new path now it's working. The flatten was definitely doing not what I was expecting. Let's remove the print statements. Now we did a debugging session after all, but felt like it was easier than creating all those continue cases manually here. Awesome. Do we want to print them? Maybe not. Let's try with those. Find path medium size. Read caves from string. Now this is our string. What I'm a little bit worried about is loops. But I guess they can't really happen with this setup. Let's see. So this should return 226 paths. Now I'm curious if we get this. That's not great. We don't. Oh, 19. Everything is great. I looked at the wrong example. Pooh. And then test find path large. And then let's copy this. Now we throw in large example. This should return 226, right? Yeah. Run the large one. Also correct. So now we seem to have the right one. Let's run all the tests. Okay, I guess we can implement part 1. Part 1. We get a cave map. And that means read caves from file. And the file is day12.txt. Right. Don't care about the new line here. And then we want to have the path. Find. Oh, it doesn't return anything. That is not great. Return the map. Let's go back to path 1. And now we search for the path. And then let's print them. Run main. 3,887. That's the right answer. Okay, let's go to part 2. After reviewing the available path, you realize you might have time to visit a single small cave twice. Ooh. Specifically, big caves can be visited any number of times. A single small cave can be visited at most twice. And the remaining small caves can be visited at most once. What again? Specifically, big caves can be visited any number of times. A single small cave can be visited at most twice. And the remaining small caves can be visited at most once. However, the caves named start and end can only be visited exactly once each. Once you leave the start cave, you may not return to it, and once you reach the end cave, the path must end immediately. Now the 36 possible paths through the first example above are... Okay. This is now a bit annoying because we have this visited list and there's only one of them that we can visit twice, which means we need to do two things. We need to know which one it is, and if we visited it already. I guess we can track both in here. So we could say small cave to visit again is a cave, and then has visited a small cave again. It is not great. And to keep this compatible, we will continue to pass in this, and we can still run our tests. And then we need a new one, which is the list of caves. Find path special. And this means we need to do this. We can just do this multiple times now. For every small cave we find in the map, we call this. So we say path is immutable list of caves. That's what we return. And now for every small cave, we run this and say this one you can visit twice. And then we set the boolean, either this or maybe we do not need the boolean. We can use our visited list and just put it into the visited list again. And I'm just realizing our path kind of is already our visited list. So this is essentially not needed at all. but we do not need to optimize it away right now. So for every key, because the keys are all caves, we filter them by this small. One is small. And let's also create an start, because I think we need this now. A small one is a cave that is not start, it is not the end, and the first character is lowercase. Okay, we only need the small ones. Then we loop over them and say current path. Continue the path from the start, and hey, this small cave you can visit again. And then we add all current path. And we also need to remove duplicates. Because we will find the exact same path again. Distinct. Now we need to just implement the visit again. Either we found a large one, or the current one is not visited at all, or the current one is our small cave to visit again, and visited count the count of this is 1 of current equals how can I call this? This is let's create a helper for this actually. If we have a list of caves, and then we want the function visited twice the cave, this returns a boolean, and this means if we count every cave that is this cave in this list. Now this is twice. Actually, we need visited once. Visited only once. If the current one is the small cave to visit, and visited, and we visited it only once, then we can visit it again. Do our tests still pass? They do. find path special. That's what we want to test. Okay, what kind of test case did we get? Now the 36 possible path through the first example goes. Slightly larger has 103 and the even larger. Okay. So now we can write 3 test cases and I hope they just pass. So now we call find path special. And this one should now have 36. No, we only found 10. Which is exactly the same as before. Why is that? If a cave is small. Print this for a second. Continue with small cave. Yeah, we do this. Our connections is larger, or if it's not visited, or if it is only visited once. We added to visited already? No. So some of them should find more of them, right? This found 0. This found 10. This found 20. Oh. 1. All of them just find 10. This means this is not working as it should. Get all connections, and if it's large we take it, if it's not visited, or if it's the current one is the small cave to visit. And do we even pass that in? Yeah, we do. Let's count the right one. Turns the number of matching the predicate. Yeah, that looks good. Why is this not working as it should? can we create a good test case to figure that out? Let's see. B is twice this one. So visiting B multiple times is what we might want. Let's simplify this for now and say so this looks good. We say, hey, with small cave B, C, and D, those are the only small ones. CBD, BCD, those we can visit twice. Should we look at, maybe we should only look at one of them for now. List of cave B. Continue with the small cave B. Okay. And here, cave. No, we need to do this differently. Only visited once. And is special small cave. Or it is our special small cave and it's only visited once. Now we print this. What do we want to look at? It's new path. And then continue current, and then only visited once and is special small cave. Visited once is special. Let's take a look. Let's see, we are AB, AB, AB. Yeah. Do we want to continue with cave B? Is it our special cave? No. Why is it not our special cave? Special equals. Oh, I know. Yeah, down here we do not actually pass this along. Yeah, now we have 30. That is much closer. So let's get rid of the prints. Let's keep this verbose version of it. And go away. This print can go away. And now we do not look only at B, but at all of them. Now we have 36. Awesome. Another bug found. And let's do this medium and large one too. This is now medium one. The medium one gets this one. As they call it, slightly larger example, and the slightly larger example should have 103. Come on, please return 103. Yes, it does. Okay. And then find special path large. And the large example is this one. No, sorry. And this should return 226. Come on, do this, please. Why? Oh, this is not the number. Oh, good. Phew. I didn't want to debug this, to be honest. Okay. Let's run all the tests. Awesome. Then let's write part 2. We get the cave map and just execute our special function. And it still needs just a number of caves. Oh, sorry. Main. That's a lot. Awesome. That is the right answer. Yeah, that worked well. We needed some debugging, even though we wrote tests, but I still think the tests were super helpful to find problems before actually entering anything on the website. Yeah, let me know how you solved the problem, and if you want to help me, just give this video a thumbs up. All right, see ya. Bye bye.